So good morning. We're going to work on a lesson 2.5 today in class. And we should be on page 189. There's 2 sections to this lesson. And we're really going to spend a lot of time in Desmos. So I encourage everybody to have their Desmos out and open. And the first thing we're going to start with is talking about the relationship between 2 variables. So if you all recall, back in 2 lessons ago, we talked about the relationship between the miles we drove and the cost of the cab ride and the time that went by and the value of our car, how it went down. And then in lesson 2.4, we talked about the variable of the number of pizzas we purchased versus the cost. And so today, I'm going to let you all get started on 1. There's A, B, and then on the next page, there's C and D. And you're deciding if you think that those 2 variables have a relationship, if there's probably not related at all. Share. So do y'all think that there's a relationship between dollars spent on a political candidate and the number of votes that they receive?
Yes.
I would say yes on that one. So they're marketing right, they're calling people, advertising, all that good stuff. What about B, an adult, their height and their IQ?
No.
No, I agree with that. So I would like to think that us shorter people are smarter, but that's not necessarily true. There's all kinds of us. Okay, what about a person's height and their shoe size?
This one I was a little confused on because I know some pretty tall people that have like pretty small shoe sizes.
I know. I do too. My niece is way taller than I am, and we wear the same shoe size. So on mine, I wrote possibly, but I mean, I think there is mostly some kind of relationship, but there are some outliers, right, that don't fit the mold. But I'd say there's definite possibility. What about D, the age of a car and its resale value?
Yes.
Okay, so that one we know because we already looked at data in lesson 2-3 about that. So next up says, is there a relationship between the total fat in a fast food burger and the total calories in that burger? So we have a table of, I can't remember, there's maybe 16 of these. I can't remember. 2, 4, 6, 8, 10 fast food restaurants and their total fat in the hamburger and then the total calories. So it looks like the In-N-Out burger has 19 total fat grams and it has 390 calories. And then look at Carl's Jr. Never heard of it. Has anybody else?
I've heard of it, but I've never been.
Okay. Where'd you hear of it? What state?
In like California.
Oh, Carl's Jr. 17 total fat grams and 470 calories. Wow. And then McDonald's by us, 9 fat grams, 250 calories. But it's a pretty plain burger, right? They're not talking about the Big Mac or anything like that. Okay, so I would like you to graph this one by hand. We're going to use Desmos, but for this problem, I'll graph it by hand, and I'm going to put the link to my Desmos in our chat. So everybody else at home is going to have to type theirs in, but to make it quickly for folks on the call, I'm going to put a link to my Desmos in the chat. But I'd like you to graph this, and it should come out something like this. Okay, don't worry about my coordinate points I wrote here. Don't worry about the line, just get your dots plotted. And I'm going to get a link to this in the chat. So I'll be ready. I'll let you keep. We can go ahead and get that graphed. Let me know when you get it graphed. And you can go to number 3. And make sure you're trying to be as accurate as possible here. Kelsey's ready. I didn't see if anybody else. Steven's ready. Carter, are you ready? Carter's ready too. Okay, let's do it. So I have mine, and then is everybody already done number 3? Don't look at my answer here. I have a few things already filled in. So the points on your scatter plot don't form a straight line. You can see that. It says use a straight edge to draw a line that you think looks like the best fit for your scatter plot. Note that it's possible that the line that fits the best doesn't go through any of the points. So I don't want you to look at mine. I'm not going to show it for a minute. I want you to take a straight edge, a piece of paper, and draw where you think, what line you think best describes the data points. And there's no right or wrong answer. It's just, we're all going to have something different. So let me know when you've got your line drawn and you're kind of moving on. Okay, I think I saw everybody. Carter, I don't know if I saw you, but I think I saw your thumb go up. So this is the line that I drew. We're just going to draw a line through there. It does not have to match mine. In fact, I don't want it to match mine because I want you all to see how this works. So Carter, did you get yours? I didn't see your thumb go up. I want to make sure. We're just taking a piece of paper and we're drawing wherever we think our line best fits the data. Here's mine on one. Here's mine on the one I made for today's video. So I made a YouTube video so you can go back and watch. They're definitely different. So where I've drawn it both times has been a little bit different. Same data, I've just drawn it a little bit different. So don't get caught up in having it perfect because it's not going to be. Because our data is not perfect, right? Okay. So I haven't heard from Carter. Maybe he's doing something. So let's go on to number 4. So there's a lot going on here. So number 4 says, identify 2 points on the line of best fit that you drew on your scatter plot and use them to find an equation of a line. So to find an equation of a line, I'm gonna do some new work because I don't want you to get confused with what I have. So first of all, we have to pick 2 points that are on your line that you drew, not necessarily 2 of these coordinate points. So I'm going to go and I'm finding it on my black line. So you're going to find 2 points and write them. And I'm going to use these 2 points. 12 and 300. Notice where 12 and 300 is a green dot. And then 6 and 100. Now I want you to use different ones. Because some of you might come up with a better predicting equation than myself, because mine was not fabulous. Okay. So there's mine. So the first thing we have to come up with is our slope. Okay. And our slope is our change in y over change in x. And so that would be, let's write down our units. So our units for y are the calories over the fat grams. Okay. So you can start with whatever point you choose. I'm going to start with 300 minus 100. And because I still started with 300 on my x on the bottom, I change in x. This is x1, y1. I have to start with the 12 because I started with the 300. So 12 minus 6. So my x and y should line up here, and my x and y should line up here. Excuse me. So 300 minus 200, 100 is 200. 12 minus 6 is 6. And then I'm going to have everybody share what they get for their actual slope. So mine is really high, 33.3 repeater. Excuse me. And this is calories per 1 gram of fat. So when everybody gets theirs done, please share, because I would love to know. Plus,
I have mine done.
What?
I have mine done.
Okay. So I'm going to keep track of them just so then I can help make sure everybody has their predicting equation correct. So what is your slope, Stephen?
My slope is 25.
Are you serious? That's what mine was this morning. Okay. Carter can share his when he gets it. And Kelsey can share hers when she gets it. And if anybody needs help getting it, just let me know. This is the first couple times we're doing it. And remember, for the most part, we're going to let Desmos do the work. It's just I want you to understand what we're doing behind the scenes.
Are you supposed to do like y2 minus y1?
Well,
Is it like
it doesn't
is it
matter. It doesn't matter because if I did y2 minus y1, I would have 100 minus 300, right? And then I have 6 minus 12. So the only thing I would have is a difference of these would be negative, right? But it's still 200 over 6. And a negative
Oh,
over a negative becomes positive. So as long as you're staying point to point, it doesn't matter which one you start with.
okay.
That's a great question.
I got 20.
20.
Yeah.
Okay. Oh, and Kelsey put hers in the chat. And then if everybody wants to click on the link in the chat, that'll help you with your Desmos. Oh, Kelsey's was 25 too. Okay. Then we have to be able to find our y-intercept. So let's write out, you're going to write out your equation so far. So mine so far is y equals, and I'm going to put my slope 33.3x plus b. I don't know b. Remember, slope and b, slope and y-intercept are the parameters, and we need those to be able to put it in our little puzzle form. That looks like our, remember our recipe, this is like our recipe, and we need to be able to put it in that form. So if everybody has theirs like this with your slope, then you're going to pick one of your points. So one of your points up here, and you're going to replace the y in your equation with your y and the x in your equation with your x. So I'm going to do 12 and 300. So 300 will go in for y. And then 33.3, your slope is being multiplied by x. So I'm going to put a parenthesis there times 12 to show that multiplication. And give me the thumbs up when everybody has theirs written. You picked one of your points. Don't pick my point because it won't match with your slope. So pick one of the points that you use to find your slope and then fill in your y and your x like this. And then let me know when you get this far. Okay, Kelsey's ready. Carter, I didn't see your thumb again. Did you have it up? Did you have yours? And make sure you got your slope. Okay, so Carter had 20. So Carter's 20 is going to go here, and then you're going to pick a point and put in your x and y. And then once you get to this point, you can go ahead and multiply your slope times your times 12 and or times your x, whatever your x was. So for me, this is 399.6. Make sure everybody's following okay. So is everybody at this point at least? Carter, Stephen. Good. Kelsey, are you okay at this point? And we can go ahead and now that we're at this point, okay, Kelsey's good. The only thing we have to do is solve for B. So because we're adding here, we're going to undo that by subtracting. So I'm going to subtract that value from both sides. So I'm subtracting 399.6. So this value here is what you're subtracting, and you should get a 0 there. So this should become, for me, this should be a negative 99.6 equals B. Now that means that's not good, but that's what mine is. So some of you might, like this morning, I got 0 when my slope was 25, but your y-intercept might not, it might be something other than 0. So I would love to know what everybody's B is.
Mine was 0.
I figured. So we're trying to find out what's the number that can add to the left-hand side, or add to this number here to B to get to 300. And mine would have to be a negative 99.6. Oh, we've got some stuff in the chat. Maybe people are commenting in the chat. Sorry about that. And Kelsey got 1 for right. Oh, oh, after she saw the right way, she got a 1. Okay, perfect. Or a 0. So hers is 0 as well. And then, what'd you get, Carter?
Mine was 70.
70?
Yeah.
Okay, no, this is totally, it could be. So now we're going to take our slope and our y-intercept, and we're going to put it into our recipe. So my recipe is my slope 33.3x minus 99.6. So you're going to put your slope into your recipe. So Kelsey and Steven, theirs is going to be like mine this morning. There's no y-intercept, it's 0. And Carter, yours should be 20x plus 70. Okay, so we're gonna have those jotted down. Okay, so that's what 4. They did not give us much room to do 4, did they? Aye. So the rest of the page on 191 and the next page are all about using TI-84, but we're not going to use that. We're using Desmos. So you can go ahead and flip to your Desmos and go to the link that I gave you. And we're going to work on number 5. So I'm going to just share my Desmos so everybody can see what the scatter plot should look like. Does everybody see my scatter plot?
Yeah.
Okay. So this is what you want to do there. Okay, so once everybody gets there, we're going to go to number 5. It says, use the procedure in the technology, which we're not going to do. We're going to do what we've done in class. And I've shown you a couple times. So we're going to go down and create a new line in Desmos. And we are going to type Y1 because that's where my data is. So if yours says something other than Y1, you're going to put what yours is. And then you're going to do the tilde symbol, which is the key to the left of your 1 key. It should look like that. And then you're going to use M and then X1, because that's where my X data is. plus B. Now you can use M and B, you could use A and T, you can use whatever letters you want. I'm using M and B just because that's what we've used forever. Everybody with me so far? Did everybody get what I got?
Yep.
Okay. So I'll make sure everybody else is with me here. So we're gonna write down, it says round to 1 decimal place. So on my paper here, I'm gonna write M and B are my slope and my y-intercept. And sometimes my slope makes sense and sometimes it doesn't. Like mine was negative for this, so it's not good, but that's okay. We'll talk about that in a little bit. So just off to the side of number 5, I'm just gonna write M equals 20.8 because we're rounding to 1 decimal, and B equals 41.4. And I also want you to write over on the right-hand side of number 5, just write R equals, and then write that R that's up there above your parameters. It says R equals 0.8984. Okay. Let's see here. Okay, everybody with me so far? So let's go back to my paper here so we can see what I've written down. So I wrote my slope and my y-intercept over here in this R. Okay, so the line of best fit is the line that the Desmos uses behind the scenes. It takes all of the points where we only chose 2. It takes all of the points and tries to figure out the line that best makes all of the data points happy. Now, it's not going to make every data point perfectly happy, but it's doing its best. Okay, and I'm going to remind everyone at home that to find your line of best fit in Desmos with data, okay, when we have an equation, we're going to type with an equal, but when we have data and we're trying to estimate an equation, so estimating the line of best fit, we're going to use y1 and that tilde symbol, mx1 plus b. Okay, and the R over here, this is called our correlation coefficient. And this correlation coefficient, they're going to address it in a couple problems, but I'm going to address it now because it's like the first thing I look at, because it tells me how happy is my data. It's a measure of happiness for my data. So the closer it is to a positive one, if it's a positive, it tells me it's a positive slope. And we can see that we have positive slope when we look at our graph. And if this were close to a negative 1, it means there's a negative slope. So if you turn to the bottom of page 194 for just a minute, it talks about correlation coefficient. Right here is where we're going to start. So if you flip the page to 194, it says this number measures how well the line seems to fit the data. The closer R is to 1, positive slope, or negative 1, negative slope. The more accurately the data you entered can be modeled using a linear equation. Here are some examples. So we're on page 194. So we're gonna look at these examples real quick, and then we'll go back to finish our data. So you can see here, which one do you think Or do you think that they either of them have a linear relationship? The one on the left or the one on the right, both or neither or one or the other?
I feel like the one on the right has maybe a little bit more than the one on the left. Just to me personally, the one on the left looks more like it could be exponential with how towards the end it starts going up a lot.
Oh, I see. I see what you're saying there. Okay, that would be curious to know, because right now we're just looking at linear, but you're right that I do agree on that. I would say this one looks a little bit more of a positive slope. This one to me looks a little more scattered. So, but everybody's eye is a little bit different. So in number 8, they talk about one of the scatter plots is a 0.19, which is not much at all, and the other one has a 0.82. And so just from my eye, I would say this one is a 0.82, which is really good. Anything bigger than 0.8 is to a statistician is really good. And then this one I would say is the 0.19 because it's pretty scattered. It's kind of hard to tell. I mean, in some ways you could kind of see it kind of going like this. In some ways I could kind of see it going like this. So, or kind of maybe like this. And this one is definitely, if there's going to be any trend, it's definitely going to be upward. So that's kind of what we're using this correlation coefficient for. That's why I do mine at the same time I get my line of best fit. So I know I'm jumping around, but it's just kind of the way they do it differently than the way I think. Maybe the way I think isn't good. So let's go back to number 5. Is everybody with me back to number 5 here? So we're going to write our line of best fit from the calculator using M and B, just like we did the one that we came up with personally. So y equals 20.8x plus 41.4. I hope everybody got the same as I did. Their line of best fit from the calculator.
I was actually going to ask you about this after class because the 2.4 worksheet was asking about this and I was a little confused.
I know, I should tell everyone just to hold off until 2.5 to finish our 2.4 worksheet. Because we brought it up a little bit in class, but not enough to, you know, answer the question and feel confident. So good question. I've had a couple of people email me. I'll message out about that. So everybody has this line of best fit. So number 6 says, use your answer in question 5 to predict the number of calories in a Whataburger, which has 25 grams of fat. How does the answer compare to the number of calories predicted by your own line of best fit? The Whataburger actually has 590 calories. Okay, so I'm going to compare the line of best fit. And then I'm going to compare to Sarah's, and yours is going to be compared to yours. And so we said the grams of fat is 25. So x equals 25. So we could use the equation if we wanted, like by hand. I'll show you what it would look like. 20.8, and we're going to put in 25 for x, and then add 41.4. Now remember, our slope and y-intercept are rounded, but I'm going to show you how to use Desmos, because by all means, you do not have to do this algebraically. We're trying to just understand concepts in this class. So let's go back to Desmos. So in Desmos, I can also go to x equals 25, which is over here. So I'm going to grab my line that it drew. And notice with my left mouse button, I'm going to click down and I'm going to move up and down, and I'm going to go right here. And hopefully I can get to 25 exactly. And yeah, there I am. So does everybody see it predicts at 560.3 calories? 560.3. So everybody see how I found that?
Yeah.
Okay. So mine, so what we're gonna do here is, I would like everyone, I'm gonna type in mine. So mine that I came up with, which was off, was, and now you're just gonna do y equals, because it's an actual equation that we're gonna tell it. So 33.3x minus 99.8. You're gonna put in yours. So there's mine in green. Mine is not close to the blue at all. Now I'm gonna put in everybody else's, and we're gonna just see, and you should put in those too, so you can kind of see the difference. So Stephen and Kelsey both had y equals 25x. Oh, I did it in the same one. Whoopsie daisy. Okay. Y equals 25x. Theirs is in black. Theirs is closer than mine. And Carter's is y equals 20x plus 70. Carter's is not too far off. It looks like it's about the same slope as the actual, right? Because 20 and 20.76. So yeah, I think Carter, yours is pretty good. Pretty close in that blue line. Nice job. Okay. Does everybody see how those are on there? So I have to, you're going to go to your own line and you're going to predict at 25. So mine is the green line at 25. Oh gosh, mine is way up here. So mine is, oh, I can't get to 25. There we are. Mine is 732.7. 732.7. Okay, so I'm going to go and share my paper again so we can do some comparison here. So, woo-wee. So it says, which gave a more accurate prediction? And the actual was 590. So the line of best fit definitely did better here compared to mine. Did anybody get closer to 590 than the line of best fit? Let's see, at 25.
The line of best fit was just slightly better.
Okay. And Carter's was the red. So yours was, Carter, yours was the red, was it? And, or, yeah. So, and Stephen, yours was the blue? Oh no, the blue is the actual one, and the red is Carter's. And yours was at 6. So Carter, yours was really close. Yours was only up by 1, is that right?
Can you go back to Desmos real quick?
Oh, I thought it was there, yeah. Here we are.
So, wait a second. Can you walk me through real quick how to do the, oh my gosh. How to do the, like the, I forgot what it's called, like that little dash line thing.
Oh, so you're going to type it just like it says right here. So in your table, is it X1 and Y1?
Yeah.
Okay, so you're going to type Y1. Just a Y and a 1. It'll automatically make it small down below. So don't worry about that. You got the Y1?
Yeah.
And then your tilde is it should be the key to the left of your number 1 key on your keypad. Do you see it over there?
Yes, yeah.
Shift in that key. And then you're gonna type it just like it says, M and then X1 plus B.
Okay.
Did you get the numbers that we have on my screen?
Yeah. Mm,
So they should be exact unless one of us typed in a data point wrong. But if you guys use my link, then you wouldn't have had to type in the thing in wrong. Did it come out okay, Carter?
Mine come out as like r squared equals 0 and
Hmm. So
then
your,
m1 equals 305.
okay, so your data, did you use the link that I sent in the
Yeah,
chat?
yeah.
And can you share your screen? Because I can see, let me stop sharing mine. You can share your screen. At the bottom of your Zoom screen, there should be a green share screen. And then when you do that, then choose the top left box. And then we can try to help you figure out what's going on. This is good. We'll be researchers. You all are doing awesome here. Okay, so, oh, you have M1. It needs to be M times X1. MX.
You said mx.
Nope, go back to my screen says M as in Mary, MX.
Oh my gosh.
That's all right. Are you back on your screen? There you go. Yep. Now go over there before the, yep. M is in Mary, X1. Yep, plus B. There you
Okay.
go. There you go. Yay, now you can stop sharing. And then you can type in the other equations if you want, type in your other one. Yeah, 20x plus 7. Good job, good job. That's the benefit of being on live, because then we can figure out what's going on. And if you stop sharing, if you don't mind for just a minute, I'm going to go back to my paper so that I can make sure everybody has this written down on their actual paper here.
I don't know how to like.
It should be at the top of your screen.
Yeah, I think at the top you can go to view options or something, and you can say stop sharing. There should be a top of your Zoom screen that should say stop sharing. The top of your Zoom screen.
Is it? Oh, I see it.
Okay, good job. Okay, that's good. We learned some stuff there. So back on your paper, on page 193 in some space, I would write this on your paper so everybody knows exactly what to type into Desmos. It's Y1, the tilde, X1 plus B. So X1 and Y1 are your variables and they have to stay that. M is going to be whatever letter you choose for your slope. It has to be multiplied by X1 and then plus B. Kind of the exact format that we've been using in lesson 2.3 and 2.4. Okay, so I did not estimate very well at all to this number 6 here. And then Carter should be estimating too. So if we go to number 7 here, it says a classic roast beef sandwich from Arby's has 360 calories and 14 grams of fat. What is your line of best fit predict for calories? Is this expected? So we're going to go to the one that not our personal one, but the blue one on mine, the one that we got from Desmos. And we're going to predict at 14 grams of fat. So the blue one at 14 grams of fat. Oh, I'm trying to get exactly here on 14. There it is. Does everybody see that? 14 grams of fat. Our predicted says 331.98 rounded up, so it's 332. $332 calories. And it says, do we think that that is a good, oh, I didn't show you how I did. Did everybody get that? Okay. I didn't know I was sharing my paper still. So I got 332 calories. Do we think that this is this expected? We're predicting the calories in a roast beef sandwich.
From like basing what we know from like the last one we did, it's
Mhm.
expected because it's lower than what the actual number is.
Okay. Anybody else have any thoughts? I say, if you go by the numbers, I would agree, but my question is should we be using an equation that predicts calories of from grams of fat for a hamburger versus roast beef? Because all of the other sandwiches, right, on the other page were all hamburgers.
Yeah.
So I would say we should not be using a line that predicts hamburger calories to predict roast beef calories. I wouldn't. Okay, so we already talked about the correlation coefficient sum. And so we already talked about 8. And then we're going to skip 9. Okay. We are going to go to number 10, which we already did. So let's just write that down. R equals, because number 10 is the lesson check. So this is the lesson, oops, this is the lesson check. And it was 0.8984. Okay, and it's a really good fit. We already mentioned that, but it's good to go over that again. This is the lesson check. Excuse me. So let's go ahead and flip the page. We've just got a couple questions left. So 11 says, based on all the work done in this activity, how strong do you think the relationship is between the number of grams of fat in a fast food burger and the number of calories in it? And what do you all think?
Based on the like how we got the correlation or correlation coefficient, that it's pretty strong, that usually as you go up in grams of fat, the calories seem to go up.
I would say so too. And then also looking at the R, the correlation coefficient shows that it's a pretty strong fit. And the scatter plot was our first indicator that I would say. So all three of those things could give us a good indicator, I'd say. Okay. So let's read down about number 12 here. We're going to do some comparisons. And whoopsie daisy. So it says, hopefully you noticed right from the beginning of our study of burgers that you don't have draw a straight line that goes exactly through all the points. That in turn means the predictions made by our equation for any sandwich are unlikely to be perfectly accurate. This will almost always be the case when finding a line of best fit for a data set with more than 2 values. Okay, that's why we call it the line of best fit instead of the line of perfect fit. The equations we're finding are models for data that allow us to make approximations and predictions. They're not exact representations of data. So 12 says, look back at the original table of fat and calories near the beginning of the lesson. Use the calculator generated line of best fit to predict the number of calories in the Hardee's burger. Then find the difference between the actual number of calories and your predicted. So essentially, we're doing what says down here. It's called the residual. Does everybody see this formula? The residual is the actual minus the predicted. And we've done this a little bit with, remember in unit 1, when we did the actual carpet measurements and the predicted and we were looking at the percent error. This is kind of like that, but we're not going to find a percent. We're just going to find the residual, which is the actual basically error that we were off. So Hardee's residual is going to be the actual minus the predicted. And so what are the grams of fat in a Hardee's? What did we have there?
The grams of fat is 12.
Grams of fat was 12. Okay. And so what did they say the actual calories were for that?
310.
310. Okay. Thank you. I could look, but okay, so 310. And then we're going to go to our graph in Desmos. I'm going to show you how I'm going to do this. We've done this a couple times, but we're going to look for 12 in our graph. And I'm just going to turn off all of these extra graphs. Over here on the left, you can click on the color in the circle and it will turn off the other graphs. They're still there. We can turn them back on. But for now, I just want to look at the predicting line. So this is our line of best fit. And I'm going to go to 12 on my line. It's very close. Oh, wait, no. Yeah, we want to find the 12. I don't remember this going through this earlier when I remember recording. It should be, I can't, can anybody else get it quite there?
Mine was yeah.
I got it. Phew. 290.5. 290.5 calories. 290.5. Okay. So we are predicted, right? I'm going to go back here for a minute to our paper. So we're taking the actual, which they said was 310, and we predicted 290.5. And we're going to subtract them. And so we under predicted, right? Our line of best fit under predicted. Not by much, but a little bit. Okay. And did everybody see where I got that before we go down to number 13?
Yeah.
Carter, Kelsey, before we move on, I want to make sure everybody's with us, has any questions.
I'm all set.
Okay. So I'm going to let you all do this because it's asking us to do it again. Find the residual for the White Castle burger. So this time we're going to do the same thing, but we're going to find White Castle's residual. So you need to find the X and the actual. And then you're going to go to the line of best fit that we had and find the predicted. And we'll see what we all come up with here. My computer is like hesitating, so hope it's not causing issues for you all there. Just gonna go down here. And I hopefully have the 2-1 worksheets done today, graded. I think maybe I had your class graded. And then this weekend, I'm going to start here and there on the projects and the reviews for everyone. I'm going to go to the 2-5 lesson check. I want to make sure it's, I think it is. So somebody want to help me out? What did we have for the grams of fat for the White Castle? What was it in our data set?
7.
7. And the actual calories was pretty low, wasn't it? 140.
Yeah.
And what did our line of best fit predict?
I rounded up 2 decimal places and put 186.7.
Okay. So in this case, we were negative 26.7. Is that what everybody else had too?
I got negative 46.7.
Oh, me too. I don't know why I looked at that. I was like, that doesn't sound like what I had this morning because I didn't subtract correctly. Well, there you go. Okay, so this one, our line of best fit, we over predicted. Okay. Anybody have any questions so far in the live group? So that ends the first part of 2-5. So why don't we take like a 5-minute break or so? When we come back, we're actually skipping forward to page, I think it's page 203. So we're going to do this problem right here. Let me go back there, make sure that it doesn't show them. Oh, geez. Okay. We're doing this problem here on page 203 when we come back. And don't worry about putting it on your own graph. We're going to do it all in Desmos. And I'm going to put the link for those in my live class. And I think I'll put the link in the recordings for both of the Desmos ones today, the burger one and the school cost in the links when I do the recordings in JetNet. So your X years is going to be your X1 and your cost is going to be your Y1. And we'll be back in just a few minutes. Real quick before we get started, I want to correct everyone on the lesson check for 2-5. He has it as rounding to 2 decimal places, so 0.90 should be the actual answer for lesson check. So just so everybody's aware of that. And we'll be back here in just a minute. Okay, so everybody ready to get started? This problem won't take us the rest of the hour, so we should be done a little bit early. And I put the link to the data in the chat box, so you should be able to click on that. Um, um, So again, if you're wondering how we got these X values, they told us that this is the average room and board for the whole United States for your tuition, room and board at colleges between the year of 2000 and 2014. And we're going to base everything from the year 2000. So the years on the left. So from the year 2000, that's our base year of 0. And so 2006 minus 2000 would be 6 years, all the way down to 2014 minus 2000 would be 14 years. So I put in Desmos, there's my X's, my X1, and my cost is my Y1. And do we think that this is a good fit, a linear fit?
Yeah, it's really, really close.
I think so too. So can you all see my screen, my Desmos screen? Yes, I think you said yes, Stephen. So here on my Desmos screen, we're going to put yes for number 1. So I'm going to let you all get started. Number 2 is asking you to find a scatter plot to find the line of best fit, which we just did. So I'm going to let you practice that, and we'll see what everybody comes up with for the slope. It's asking us to do some predicting. So I'll check in with everybody on number 2 here in a minute. Just to make sure everybody got the lesson check that I corrected myself. It asks us to round to 2 decimal places. In JetNet, I checked, it's 0.90. It's question number 10 from the first set of questions that we did. And I'm going to share my Desmos screen just to make sure everybody can see. This is what we should have gotten for the cost of going to college, our slope and our B, our y-intercept. And then on number 7 on the page 203, that's where it talks about the correlation coefficient. So I went back there and just wrote this down. R equals 0.996 right here. It has it in our output. And it looks to be an extremely good fit from what I can see. So I wrote my equation here in number 2, my line of best fit, line of best fit, and it's really good. And number 7 is my correlation coefficient. So what is the slope and what does it mean? There's my slope. And anybody want to share with what they think it means from my lab class here?
That when using the line of best fit, the cost gradually increases by that much.
Okay, and so when we write it out, I want you to be specific on the units. So the average cost of college in the US increases, right? Because 795 is positive, increases by $795.07 each year. So as long as you address the X is increasing by 1 right here in its units, and then what the Y is increasing, which ends up being your slope and the unit rate, make sure you're giving me that whenever I ask you for what does it mean in context. I want you to give me a good description like this. If you don't address the values in the units, I'm going to count it wrong. So that's important to be able to do. Any questions on number 3? Anybody? Okay, so let's look at number 4. It says use your equation to predict the total tuition, room and board in 2019. So X in 2019, we have to subtract 2000 because that's our base year, right? So X would be equal to 19. So I'm going to go to Desmos here, and I'm going to go to 19 way over here. I'm going to grab my line of best fit, and I'm going to go up and get to 19 as close as I can. And there it is. So we came up with 25,000, you can round it to even, $25,733. Okay, and then I'm gonna let y'all keep working here. So number 5 is doing some predicting, but we have to go back to the future. So we're actually going back in history. So I'm gonna pause and let you all finish working on it. Okay, so number 5 about the college class is asking us to predict what the average cost of college would have been in 1990, which is before we have data, right? Our data starts at 2000. So 2000 minus 1990 is 10 years before. I should have started with 1990, but so X is really a negative 10. So when we go down to our graph here, and I'm going to go to negative 10. So I'm moving my graph over. Can everybody see my graph? I'm going to go to negative 10, and I'm going to, oops, trying to get right at 10. There we are at 10. It says the average cost of college back then is predicted to be, I don't know what it actually was, $2,675.92. 92. Pretty inexpensive. Now, number 6 says use your equation to predict the school year in which total tuition, room, and board will reach 30,000. So this is different. This time they're giving us the Y and they want us to predict the X. So we could do this with algebra if we wanted. We could have done the other one with algebra too, as well. So this is what we had for number 5. So number 6, we want Y to equal 30,000. So we could set it up equal to our equation, right? 795.07x plus 10,626.60 and solve for X. Or we can just go to Desmos and because it's a Y, we could say, well, let Y equal 30,000 and hit enter, and we don't see it because it's way up here. So I'm going to, and that's a bummer that they gave them the same color. But I'm just going to click on them and it should go in gray, and it looks like right there. So year about 24.4. So 24.4 years. And that means that would be the year 2000 plus 24 years. So we're predicting around year 2024, it will be at 30,000. And I'm going to stay right here in Desmos because, sorry, number 8 is asking us to find the residuals for the year 2002 and 2003, and then also for the year 2008, 2009. And what do they mean? So we're gonna do it for both. So we're gonna need Desmos for that. I'm gonna show you real quick on my paper how I would write this. So this is the year for number 6. Number 7, we already had filled in from our correlation coefficient. And number 8, we're finding the residuals. So for 2002 residual, we need the actual from 2002, which on the other side was 12,014. So I'm going to write it underneath. And then we need to find the predicted for 2002. So we need to know that is x equal to 2, right? So let's go to our predicted in Desmos. And this one I'm going to do, and then I'll show you how to do the next one. So I'll let you try to do this one on your own. So for the predicted here on my, I got 12,000. Oops, I got to go to my line and go up to 2. And almost there. I just am having struggling to get it right on it. There it is. 12,216.8. Point like 76 or something. Subtracting. This comes out to be 12,014 minus 12,216. So this is a negative $202.76. So it wasn't over by much. We over predicted a little bit. Oh, I'm already there. We over predicted a little bit. Excuse me, but just over $200. I am okay. So we over predicted. Just a little, and you can see that on the graph. So I'm going to go to Desmos. We're going to do the next one in Desmos here so you can follow along. So you can see that in 2002 and x equals 2, the actual is the green dot, and you can see our predicted line is above the green dot. So now for the 2008, x is equal to 8. And so the actual for 2008, we said was 17,092. 17,092. And we're going to go to 8 in Desmos. And you can see on 8, year 8, the actual green dot is above our predicted line. So it looks like we're under predicting on this one. And so I'm going to go to the blue line and I'm going to go up to 8. Do my best to get it right at 8. Oh, there it is. 16,987.21. 16,987.21. And there we go. Okay. So our residual here minus 16. So it looks like we under predicted, and we were even closer on this one, right, by $104.79. So we under predicted. So what do you think?
I mean, the results mean that it's obviously not going up exactly in a linear line.
Mhm.
And it could drop off eventually and flatten
It could, yeah.
or exponentially go up.
Mhm. So you think this looks exponential?
No, I'm not saying that it looks exponential, but I'm just saying that with the data we have, it just shows that like the line of best fit is very close to linear, but it's obviously not exact and it could go up or down.
That's true. But the R is so good, it's gonna be hard to beat that. So, but we are going to come back on Tuesday and we are gonna work on lesson 2.6, and it's all about exponential. So we've been doing like lesson 2.3 and 2.4 and 2.5 of all about linear equations and linear modeling. And now we're gonna jump to exponential modeling, which lines up with that compound interest that we were growing by multiples, repeat multiplication in lesson 2.1. And so we're going to do that in 2.6. And I will have the YouTube videos for 2.6 hopefully done tomorrow, so that they are ready to go. So anybody wants to get ahead and start working on those, they can. So we're done for the day, but I'm happy to stay on and answer questions about the 2.3 worksheet or 2.4 worksheet if anybody wants to ask those.
I'm good on the 2.3 worksheet, but I'm gonna work through the 2.4 and 2.5 right now while we're here.
Okay. Sounds good. I'm going to